So this video is going to talk about proposition 8.1 and why it's true. So the underlying assumption that we have right now is that we're in an incidence geometry where all the betweenness axioms are satisfied, as well as the three congruence axioms for line segments. Now, proposition 8.1 says that congruence is an equivalence relation acting on the set of line segments. So there's a couple of background pieces of information that we need to know. First of all, the operation that we're dealing with is congruence, and the things that that operation is going to be acting on are line segments. And we also need to know what in the world is an equivalence relation. Okay? So an equivalence relation is just a way that things are related to each other, hence the name relation. But equivalence relation means just three properties. The first one is the reflexive property, and the reflexive property says with whatever operation you have, in our case congruence, the item that you put on either side of that operation has to be the same. And then what you've written down is true. So in our case, this means we need to know that AB is always congruent to line segment AB. The second property you have to be an equivalence relation is the symmetric property. And the symmetric property says when you use whatever your operation is, it has to not matter which order you write the things on either side of that operation. So if you start off and you have AB is congruent to CD, it still has to be true if you flip-flop the order and write CD first and AB second. And the last property that you have to have in order to be an equivalence relation is you have to have the transitive property. And this is where if you have two pairs of congruences, so AB is congruent to CD, CD is congruent to EF, well, you're able to link them all together and get the result that, hey, all three of these guys were really congruent, namely AB was really congruent to EF. So what we're about to do is we're actually going to prove that these three properties hold true when you're dealing with congruence and line segments. So let us go back and focus on each of these one at a time. So when writing a proof in Hilbert geometry, you can do the same techniques that we've done previously. You start off with your reasons and your statements. And I'm going to claim in this one it's almost so simple we didn't have to write a chart, because I'm going to say it's literally one statement. Okay? So I'm going to claim that it is almost automatic that AB is congruent to AB. Now, this is the point where you're going to want to stop the recording and go and get the handout for section 8, or at least go and get the statements for the three congruence axioms for line segments. So C1, C2, C3, we're going to need them right now because we're going to use them for citations. With proposition 8.1, we are only assuming the consequences of incidence betweenness and then just the axioms C1, C2, C3. We are not assuming any other results yet other than definitions. Okay? So stop the video and then come back and we'll start citing this. Alright, so I'm going to assume that you've got the three axioms in front of you. So take a moment and look through those three axioms, C1, C2, C3, and see if you can identify any of those three axioms that would give us the reflexive property, give us that A is always congruent to A, because my claim is we can literally do this in one step. Okay, I'm going to assume that you've spotted one, and hopefully the one that you spotted was C2. That second sentence in axiom C2 says what? It says every line segment is congruent to itself. Well, that's exactly what we wanted. So bam, the reflexive property is taken care of. So let us move on to the symmetric property. Now the symmetric property, we have to do a little bit more. So when we will go ahead and prove the symmetric property, again, I put it into a T-chart. Our starting point here is before this implication arrow, so we know that we're going to assume that line segment AB is congruent to line segment CD, so that's given. Now, it is not automatic that the reverse is true. Now, we've worked with line segments. We know it should be true, but we have to explain why it's true. So this is where the only things we're allowed to use so far are our three congruence axioms, C1, C2, C3. We now can use the reflexive property because we just showed that it was true, and we can use any of the properties back from section 6 and 7 that we had dealing with incidence or betweenness. Hint, we're not going to need any of those guys. Okay. So it turns out that what would be absolutely amazing to use is one of our congruence axioms. And the congruence axiom that would be really awesome to use is C2. Now, why would C2 be useful to use? Well, one of it's a process of elimination. The first congruence axiom is copying a line segment. not useful. The last congruence axiom, or the third congruence axiom, is roughly speaking adding two line segments together. Again, not really applicable. So we've only got that middle one really to focus in on. Now, we already used that every line segment is congruent to itself, so we look back at this guy and we see that, hey, AB congruent to two different line segments means those two other line segments have to be congruent to each other. So we say to ourselves, okay, well, we need two different guys to be congruent to each other. Maybe there's some way that we can use this. And the way that we can use this is, notice location. So CD here needs to be the first person in our conclusion, so that actually matches. AB needs to be the second one in our conclusion. Okay, so EF here really would be AB. So if we look to see if we can just swap out the EF in the statement of the congruence axiom, we'll see if this actually works. Now, we already have that line segment AB and CD are congruent to each other. If we swap out EF with AB, that would tell us that AB is congruent to AB. And we remind ourselves, hey, that was the reflexive property. And remember, the reflexive property was actually the second sentence inside of that C2 axiom, so you could use either of them here. I would actually recommend using reflexive property simply because it highlights that second sentence. Then I'm going to claim that if we apply C2 to these two first statements, AB congruent to two other things, we will then get that CD is congruent to AB. And once we have that result, it doesn't matter the order in which you write your line segments. If two line segments are congruent, you can keep rearranging the order and they will still be congruent. And then the last property we need to worry about is the transitive property. So with the transitive property, we need that we're going to start off with AB is congruent to CD, CD is congruent to EF, and the conclusion is we need that AB is congruent to EF. Now look through your congruence axioms, take a moment to do that, and see if any one of those congruence axioms look like they might be useful or helpful. And just like before, process of elimination, first congruence axiom deals with copying line segments, so not super useful. Third congruence axiom deals with adding line segments, also not super useful here. And this middle, or the second congruence axiom, deals with some logic. And if you look at the write-up of the second congruence axiom, notice it looks almost exactly the same as the transitive property here. There is a difference, and the difference very much is, notice the line segment in common here is line segment AB. Here it's a CD. Now just the name's changing, not that big a deal, but positionally, the line segment AB up here is in the first position right there. Here, in transitive property, one's in the second position and one is in the first position. So notice it's not exactly the same as C2. For that reason, even though we're totally going to want to use this axiom C2 to get us our final answer, we need to do a little bit of prep, okay? So prep-wise, I went ahead and said the two pieces of given information, I went ahead and actually put them in statement 1 and statement 3 because I want to rewrite this first statement of AB congruent to CD. I actually want to flip-flop it and write it as CD is congruent to AB. Now notice that's totally allowed because we've already dealt with the symmetric property or symmetry. So once we've gone ahead and flipped that first congruence relation right here, this first pair of congruent line segments, notice now we have what? We have the first line segment of both of these two equations with the congruent symbol are matching, which means we now have the perfect setup for C2. And if we apply C2 to statements 2 and 3, this yields AB is congruent to EF, and that was totally trying to be a squiggle and flattened out on us. And that gives you the transitive property. So, sum up real quick. In terms of what we did, we made baby t-charts for all three of these properties. The reflexive property was totally true because it was exactly one of the sentences in the second congruence axiom. The symmetric property was also using the reflexive property plus that same second congruence axiom. And for the transitive property, it still used that same second congruence axiom, but now it used symmetry as well. So notice reflexive, symmetric, and transitive properties all were consequences of that second congruence axiom that dealt with, well, let's face it, how you can deal with algebra and logic with congruences and line segments. And the nice thing about this proposition is what it gives you is it allows you to basically do whatever it is that you wanted to do from a algebra standpoint on your line segments and your congruence relations there.